Hello and welcome to Casual Learning. I'm your host, John Bannon. In today's video, I'm going to go over chapter 2 of my newest book, Superdeterminism Defeats Atheism. You can get this book on Amazon Kindle. I'm going to break up my videos of chapter 2 into part 1 and part 2. Part 1 is going to be about Dr. Hansson's proof. Dr. Hansson's proof was published in Physics Essays, Volume 33, Number 2, in June of 2020. You can find it online, read it yourself. It's only a 3-page proof, and it's entitled Bell's Theorem and Its Tests, Proof that Nature is Superdeterministic, Not Random. There are two versions of superdeterminism. There's the original version, which relies on causal hidden variables that from the beginning of time or the Big Bang have caused the sequence or chain of events that have led to the non-local correlations seen in the spin measurements of entangled particles. However, there is a new and different version of superdeterminism. That's the version that Dr. Hansson proved. And the key to understanding his version is it does not rely on causal hidden variables. In fact, it disproves continuous causation in physics, which means it can't rely on causal hidden variables because he's disproving causation itself. And the key point from Dr. Hansson's proof is that continuous causation is not real. Very simple fact about the universe, but very profound and very important to disproving atheistic ideology. So I'm just going to focus on Dr. Hansson's proof. So what I'm saying doesn't necessarily relate to the original version of superdeterminism, which is much more problematic than Dr. Hansson's version. So I'm just sticking to Dr. Hansson's version for these videos. But it's very important that you understand that I'm talking about a different and new version of superdeterminism, one that not many people know about, mainly because this proof just came out in 2020. So Dr. Hansson's version of superdeterminism says that everything that happens in the universe is predetermined, but not as a result of it being caused to be that way over time. So he's disproving continuous causation. So his explanation is not going to be it was caused to be that way in time. Rather, he's going to say that the universe appears and behaves the way it does due to a static ordering of timeless hyperplanes of space-time in our block universe. So it's not causation that is causing the behavior of the universe. It's that the universe is a static block and it happens to be, it appears to be ordered in that way. So a static ordering of an appearance of causation is essentially an illusion of causation, but you can't tell the difference besides Dr. Hansson's proof that you're dealing with an illusion of causation as opposed to actual causation. So Dr. Hansson is basically pointing out something pretty obvious, which is that in an Einsteinian block universe, Einstein said that our experience of time is an illusion of the block universe. That's nothing new. But Dr. Hansson is saying, yeah, but that also means that cause and effect in time is also an illusion. So continuous causation is not real. It's just an illusion of ordering in our static block universe. This is not a giant leap from Einstein's block universe. Okay, so in other words, Dr. Hansson is proving that the universe is a predetermined static block universe without continuous causation in physics. And since physics governs the behavior of everything, then it's the same thing as saying continuous causation is not real. Now, the idea of the block universe is nothing new, and it has been around since at least 1905 when Albert Einstein published his theory of special relativity. What is new is that Dr. Hansson published a proof that continuous causation in physics is not real. Um, So, because that's the important part of Dr. Hansson's proof that continuous causation isn't real, that's what I'm going to focus on in this video, explaining how he gets to that proof. So, Dr. Hansson's proof is simply an application of Einstein's theory of special relativity, namely the relativity of simultaneity, to the typical um, quantum entanglement spin measurement experiment. So Dr. Hansson uses one of the most surefire theories in physics, the Einstein's theory of special relativity, and what is generally known to be true about correlations seen in entangled particles to make his proof. That's why he calls it a proof in the title of his paper. Um, However, in order to understand Dr. Hansson's proof, you need to understand where Einstein got his idea of the block universe. Because you've got to understand the concept of the block universe to understand Hansson's proof. So, Einstein's idea of the block universe began prior to 1905 when science discovered the constancy of the speed of light. Now, what the constancy of the speed of light means is that regardless of how fast or slow you are going, the speed of light will always be the same rate for you. When you measure it, it's always going to be the same speed. So, for instance, if you have a headlamp on the front of a bicycle and you're riding that bike along and you're going 15 miles an hour, when you turn the light on uh, and a beam of light shoots out from that headlamp, when that beam of light is measured, it will always be the speed of light. It won't be the speed of light plus the 15 miles per an hour that you're um, riding that bicycle towards the person who is measuring the speed of light from your bicycle. It'll always just be the speed of light. So you don't add or subtract from the speed of light depending on how fast you're going or what your velocity is. The speed of light is constant for all observers, regardless of their relative velocities to one another. Now, this is a very, very strange fact about the universe. And this is the fact that Einstein used to formulate his theory of special relativity. So, uh, to explain what the constancy of the speed of light means in real terms, as to what's going on in our universe, Einstein came up with something called the train paradox. So I'm going to explain the train paradox to you to show you what this means. So Einstein thought of a train. This is a thought experiment, and it's traveling in one direction down the tracks at, it doesn't matter what the speed is, but let's just say the average speed of trains, okay? So there's a train going down the tracks past a platform. And on the platform, there's an observer. But in the train, there's also an observer. And the train is going in that direction. While the train is moving past the platform, uh, two uh, lightning bolts strike the front and the back of the train. Now, the observer standing on the platform sees the light from these lightning bolts at the same time. He's stationary. The bolts go off at the same time relative to him. So the light travels the same distance to him. So he sees both lightning bolts at the same time. So from his perspective, the lightning bolts struck simultaneously. However, there's a passenger in the train, and the passenger is going in this direction at a certain speed. So for this passenger, that passenger is going to see this lightning bolt before that lightning bolt because the train is going in this direction and they're going at a certain speed. So this passenger is got to see this bolt first and this bolt second. However, and this is the key to the train paradox, due to the constancy of the speed of light, this person cannot measure the light from this lightning bolt to be faster than the speed of light. It has to be the same speed as the speed of the light from this lightning bolt reaching the passenger. That's a weird fact about the universe, but it's also experimentally proven to be true. Consequently, Einstein realized that the only way that this passenger could experience the light from this first lightning bolt to be at the same speed as the light from this lightning bolt would be if this lightning bolt relative to the passenger struck first in time itself. So in order to accommodate the constancy of the speed of light, Einstein realized that time had to be different. The time for this lightning bolt had to occur before the time of this lightning bolt for this particular passenger. That's the only way that you could maintain the constancy of the speed of light for this particular observer. Well, that means that there's different times, different now moments for the passenger and the observer on the platform. So Einstein realized how is it that you could have different now moments or present moments for different observers? He thought, well, everybody thinks that everybody experiences the same passage of time. So how could you change time depending on the observer? And the answer is the block universe is what allows you to do that. So Einstein realized that the universe has to have a fourth dimension. That is the dimension of time that allows different observers to see a different sequence of events. That is what Einstein called the relativity of simultaneity. So, in other words, what this observer regards as simultaneous is different than what this observer regards as simultaneous, depending on their relative frames of reference. Okay, so Einstein proves the existence of space time, that is, three dimensions of space, length, width, height, and an added dimension of time. In other words, a fourth dimensional space time or block universe. So Einstein proved we live in a block universe. Dr. Hansson uses Einstein's special theory of relativity and his understanding that the best way to interpret something like the train paradox is through a block universe to prove that continuous causation is not real. So, what does Dr. Hansson do in his proof? He sets up the typical uh, quantum entanglement spin measurement experiment. And he asks, well, how is it observed depending on your relative frame of reference? And because of the Einsteinian block universe, then the different sequences that are observed proves to us that continuous causation in physics is not real. So Dr. Hansson imagines a simple experimental setup. Let's just say a lab table. And on this lab table, there is a spin measurement device on either end. And then there's a lead scientist who's making the measurements. So there's a spin measurement on one end of the table, let's call it A. And then there's a spin measurement device on the other side of the table, let's call that B. So quantum entanglement has this strange but true non-local phenomenon. And what happens is when you take two particles and you entangle them, such as photons, which is a particle of light, when you measure the spin of one of those particles, the spin of the other particle will always be the opposite spin, regardless of how far apart you put those two particles when you measure them. So you could take two entangled particles, keep one here, put the other one on the moon. And when you measure the spin of the one on Earth, and let's say you find out it's clockwise, you know automatically that the spin of the particle in the moon is going to be counterclockwise. And there's no way these two particles can communicate with themselves fast enough to correlate uh, their spin measurements as exact opposites, because any communication can't go faster than the speed of light. And you can separate these particles so far apart and then measure them such that there's no way that they could be communicating with one another in order to correlate their measurements. And the thing with quantum entanglement is that when you measure the spin measurement of one of the particles, due to the laws of quantum mechanics, we know that the odds of you getting either a clockwise spin or a counterclockwise spin is always purely random. It's 50-50, 50-50 chance. So what Hansson is doing is he's using the unique properties of entangled particles or photons to prove that causation is not real. So Hansson imagines this laboratory setup, and then he imagines, well, what would happen if you had observers also looking at this experiment, but coming from different directions near the speed of light, such that Einstein's theory of special relativity would come into play. Now, I'll try to sort of give you an idea of what the block universe means. In the block universe, uh, the the order in which you observe a sequence of events can be different depending on what angle your frame of reference cuts through the block universe or through the four dimensions of space-time. So to give you a easier way of understanding that, how the sequence of events could be different, I'm going to use this ruler to show you. So imagine there is an experimental setup like this, a lead scientist, and he decides to measure the spins of two entangled particles, one on either end of the table, simultaneously. So he observes the spin measurements occurring at the same time. Now, how is that possible for him? Well, imagine he's traveling through the block universe and he's cutting a parallel angle or straight angle through the block universe. So what happens is, let's say this is his frame of reference. So his frame of reference is cutting through the four dimensions of space-time. And he sees both measurements occur at the same time, simultaneously. Now imagine that somebody else observing this same experiment is coming in from this direction near the speed of light, such that there are relativistic effects that you could observe. So in his frame of reference, going at that speed, he's cutting a different angle through the the four dimensions of space-time. It's a different angle through the block universe. So what happens is he sees B measured before A. And how that happens is he's traveling at a different angle through the block universe. This is his frame of reference. So his frame of reference moves in this direction, and he notices B before A. Now you can say the same thing about an observer coming in from the opposite direction near the speed of light. But this observer is going to see A measured first because he's coming through the block universe at a different angle than this guy or this guy. So his angle is like this. So he sees A measured first, and then B. So these guys are all traveling through the same 4 dimensions of space-time, this block universe, but their frame of references are at different angles as they travel through that four-dimensional block universe. Consequently, they can see a different sequence of events in the same static block universe. Okay, so Dr. Hansson is a accomplished theoretical physicist from Sweden. He works at a university. He understands Einstein's special theory of relativity, and he understands the block universe, and he understands that that's what happens in the block universe in the typical quantum entanglement spin measurement experiment. But what he points out is that, oh, wait a minute, reality is the same for all 3 of those observers. They're all in the same block universe. None of them have a preferential frame of reference. The events, the spin measurements, are independent events in the universe. They don't change for anybody, regardless of your frame of reference in the static block universe. What can change is the sequence in which you see the events occur, depending on your frame of reference in the block universe, depending on how your frame of reference is angled to slice through the same block universe. So Dr. Hansson points out that, hey, wait a minute. This guy is going to see B measured before A. This guy is going to see A measured before B. And this guy is going to see A and B measured at the same time. But they're all witnessing the same independent event in the block universe. Their observations don't change the block universe. They don't change the events. So what does this mean in terms of continuous causation in physics? Well, it means a lot. So here's Dr. Hansson's proof in a nutshell. Because we know that entangled particles, when measured, have to give opposite spins. So if one is clockwise, the other is counterclockwise. Then we know that the spin measurement of one can't actually cause the spin measurement of the other one. Because if that were true, then you wouldn't be able to maintain 100% exact opposite correlations depending on your frame of reference in the block universe. So for instance, if you see A measured before B, and you say that the measurement of A actually causes the opposite measurement of B, then you're put in a position where if this guy over here sees A measured before B, but you see B measured before A, and each measurement is a 50-50 purely random chance, then your measurement results are going to be different sometimes. They're going to be different because you're seeing one measured first and the other guy seeing the other one measured first. And if that one that's measured first actually causes the measurement of the second one, and you guys are seeing different particles measured first, then your results cannot always be correlated exactly the same, which means you'd have to see different measurement results depending on your frame of reference. But that's a violation of Einstein's special theory of relativity. That's what Dr. Hansson is pointing out. So these guys, their measurement results, the spin measurement results, always have to be the same because these are independent events in space-time. They can't get different results. So the only way that you can get the same results in your spin measurements, regardless of what frame of reference you're observing the events, is if the spin measurement results are predetermined for both observers. They can't be changed because they're predetermined to be what they are. And if they're predetermined, it means that one is not causing the other. It's certainly not a random 50-50 chance. It only appears to be a random 50-50 chance because that's what it's predetermined to appear to be. But it's not actually a caused 50-50 chance. It's actually a predetermined appearance of a 50-50 chance. So that's what Dr. Hansson uses to prove that continuous causation cannot be real. Because if it was, then these guys could not always have the same measurement results in the typical spin measurement experiment for entangled particles. So Dr. Hansson uses a surefire physics theory, Einstein's theory of special relativity, to prove that causation in time is not real. What does this mean? It means that we live in a static block universe, an Einsteinian static block universe, but that what happens in the universe is not actually caused to happen in time. It's simply a static appearance of causation or an illusion of causation. That's what Dr. Hansson is proving, that cause and effect in time is an illusion of a static block reality, which is predetermined to appear a certain way. And when you uncover events like this, it's not that they're causing each other, it's that you're simply uncovering what is already there, what's already predetermined in the static block universe. So that's Dr. Hansson's proof in a nutshell. And it's based on Einstein's theory of special relativity. It's based on what is absolutely scientifically known about the typical quantum entanglement spin measurement experiment. And that's why he calls it a proof. And the takeaway as far as uh, disproving atheism is that continuous causation is not real. So I invite you to find Dr. Hansson's proof on the internet for yourself. Read it for yourself. It explains everything, probably a lot better than I just did, but take your time with it. Understand the relativity of simultaneity, what the block universe is. Read this proof, and then you will understand that what Dr. Hansson is essentially proving is that continuous causation in physics is not real. And Dr. Hansson's proof conveniently gets out of Bell's theorem because Dr. Hansson is using a little known fourth assumption of Bell's theorem, which is that continuous causation in physics is real. And he's proving that continuous causation in physics is not real. So that's how he's getting out of Bell's inequalities and Bell's theorem. So he's able to prove that instead of some sort of spooky action at a distance going on between these entangled particles in order for them to correlate as exact opposites regardless of the distance in which you do the measurements. He's showing that it's really a result of a realistic, predetermined static block universe. So the correlation is caused simply by a static appearance in the hyperplanes of space-time of the universe. And you're simply uncovering what's already there. So the correlation isn't something that's being caused between these particles. Rather, it's it's uh, it's a correlation that pre-exists, that in the predetermined static block universe that's already there, that you're simply uncovering. Um, so uh, look up Dr. Hansson's proof, read it for yourself, understand what he's saying, and it's true because he's using Einstein's special theory of relativity, which has been proven over and over again as true. He's using what everybody already knows about the opposite spin correlations of entangled particles. He's simply applying Einstein's theory to quantum entanglement and is concluding, and rightly so, proving that continuous causation in physics is not real. All right, so the next video, I will continue on chapter 2, which is entitled Superdeterminism, and I will explain what the consequences of this proof is in terms of free will. All right, so see you next time. Bye.